What we get here is stones projected vertically upwards from ground level, initial speed u. After 1 second it will reach a height of 16.1 meters. Find the value of u. So look lads, that's a very easy start off. Okay, so the easy start off is u vast, UVAST. It starts at an unknown speed, okay? The unknown speed is going to be u, okay? After 1 second, t equals 1, it reaches a height of 19.6. Its acceleration, lads, is it getting faster or slower as it's projected vertically upwards?
16.1.
16.1. It's getting faster or slower as it's projected vertically upwards? Slower. So that's a deceleration of minus 9.8. Your whole point is to find out what u is. You want u, you have a, s, and t. It makes sense to use ut plus a half at squared. So you have 3 choices of formulas, and your whole point of this question is to find out. The whole point of the question wants to find out the value of u. You'll notice that u is in all 3 equations, but why you don't choose the other 2 equations is you don't know what v is either. So anything with a v in it automatically gets ruled out because you don't know what v is either. So you might as well do ut plus a half at squared. So you're going to get 16.1 equals ut, which is going to be u times 1, which is u, plus a half at squared. A half of a is minus 4.9, and t squared is 1 squared, which is 1. U therefore is 16.1 plus 4.9, which is 21 meters per second. It's not too bad, lads. We're at 21 meters per second. Yes?
How did you get the minus 9.8?
Minus gravity. Gravity is always 9.8. Always. Okay. Now, what happens next, guys, is we're going to be doing is find the greatest height reached. So guys, the greatest height reached is when you go all the way up, and so that's what's happening to your object at the moment, right? And at its greatest height, its speed equals 0. So v equals 0 at its greatest height. So if you fill out your u vast again, this time around you don't know the time taken, you don't know the distance, you do know that it's minus 9.8, you do know that v equals 0, and you have your u value of 21 from the first question. Now, it asks for the greatest height reached, which is the s value. Okay? Which equation would you choose to get the answer directly out? Using one equation only. V squared equals u squared plus 2as, because you have v squared, you have u squared, you have 2a. Only thing you need is s. Only one variable missing. So it's going to be 0 squared equals 21 squared minus 2 times 9.8. 19.6s. What's 21 squared? Is it 441? Okay, so minus 441 when you move it over to the left side equals minus 19.6s. What is 441 divided by 19.6? Sorry? 22.5. So the height is 22.5 meters. Everybody happy with that? Now, the time spent in the air before it hits the ground. What you got to remember about this flight is it's symmetrical, okay? So the part I just did there, when I started off, greatest height reached, yeah. So what I did at this part was I said you start off with u equals 21. You're going all the way up you're hitting the very top, okay, and that takes you 22.5 meters into the air, okay. Now the thing is, it's symmetrical. The time taken to go up equals the time taken to go down. So if I find the time taken to go up, double it, I'll find how long I spent in the air. So what I can do for the next part, what I can do for the next part is use V equals U plus AT. So this part here. So V equals U plus AT, and then we're going to use 0 equals 21 minus 9.8t, and then 9.8t equals 21. T therefore is, what's 21 divided by 9.8? 21 divided by 9.8? Something a bit more precise?
15/7.
15/7. Now guys, this 15/7 is the time taken to go from here up to here. I need to double that because it takes the same time to get all the way back down. So 15/7 multiplied by 2? 30/7 seconds. Okay? Any questions on that one? Anything that still doesn't make sense? Okie dokes, moving on. A particle is projected upwards from the ground with an initial speed of 47 meters per second. 2 seconds later, a particle Q is projected upwards from the same point with initial velocity 64.6. Calculate how long Q is in motion before it collides with P. Okay guys, so 2 sets of UVAS. Let's call that P. And let's call this one Q. 2 different sets of data. Now starting off with P. So what happens is one of them's thrown upwards, starts travelling upwards. The second one is thrown at a faster rate upwards and eventually catches it up and collides. We had to figure out, so it's like, what are the scenarios that happens here guys? What are the scenarios?
It is on the way up.
Scenario A is that it catches it on the way up. Scenario B is that P is on its way back down as the other one's still on its way up. So there are 2 scenarios. Haven't got a clue which one it is yet, nor do I need to really know which one it is. So U is what guys? What are we going to put U as? Anybody know? 57 minus 9.8. S.
57.
Let's call it S. That's 47. S is still S. T is T plus 2. Why are you calling that T plus 2?
2 seconds longer.
It's 2 seconds longer than the other one. What would be an alternate system to that?
T minus 2.
T and T minus 2 would give you the same result. Okay? It's in the air 2 seconds longer, so it's T plus 2. Now S is still equal to S because why are the S's the same? Their displacement, when they hit each other, they got to be the same length apart. So the whole point is your one key to doing this whole question is S1 equals S2. Now how long Q is in motion before it collides with P? How long, I would say, if that's a time question more than likely. It could also be interpreted as a distance question, or how long did it travel would be a distance question. So I'd say it's time. It's a time question. Now, U for this one is 64.6. V we haven't got a clue. A is still minus 9.8. Sorry, V we don't know what it is. Now, what formula are you going to choose? Huh? UT plus a half AT squared. Why did you choose that one? The S values are the same, so therefore they're comparable. The U value you know. The T value is the same variable in both of them. V would be a horrible choice for this question once again. Why would V be a horrible choice? Because the V in both information sets are completely different and unrelatable. one of them could be travelling 2 meters per second into the air, the other one could be travelling 20 meters per second into the air just as it catches it. They're unrelatable, you don't know anything about them. So that's why we have to avoid V at all costs. Okay? So let's do, this is in green, so this relates to S subscript P. Distance that P travels is going to be 47 times T plus 2. Plus, sorry, that's going to be now minus half of gravity, minus 4.9 T plus 2 squared. Okay. Multiply this out, 47t plus 94. This here is going to be t squared plus 4t plus 4. Okay, t squared plus 4t plus 4. I'm now going to start using capital T's because my T's look too much like pluses. So, okay, so I'm going to use capital T from now on. Now, what we have here is 47 multiplied by t minus 4.9 t squared. So I have to multiply everything here by minus 4.9. Everything in there gets multiplied by minus 4.9. So it's going to be 4.9 t squared minus, what's 4 times 9.8? 19.6? T minus another 19.6. Add them all up together and we get SP equals minus 4.9 t squared. What's that? 47t minus 19.6 t. And we know 47 minus 19.6? Huh?
27.4.
27.4 minus 27.4 t. And then 94 minus 19.6. 94 minus 19.6, anybody?
74.4.
74.4. Okay guys, this here is all just SP, nothing to do with SQ. So I'll come up here and make more space regards the next part. So just get rid of all the workings here. Okay, now we're going to go up and find SQ. Now, SQ is the same deal, 64.6 T minus a half of A, 4.9 T squared. As discussed, S1 equals S2. Put them equal to each other.
It's plus 7 or plus 27.4.
Is it? Oh, sorry. The last one is plus 27.4, excuse me. Okay, so then we put them equal to each other. Now, the first thing to go is the t squareds. And the next thing we're going to do is we're going to leave the 74.4 where it is. And then over the other side we're going to do 64.6t minus 27.4t. And what happens when you take away the two of them?
37.
That's it, is it? It's a very convenient number. And then t therefore is 2. So what does that mean, t being equal to 2? Q is in motion for 2 seconds, while P is in motion for 4 seconds. The height at which the collisions occur, now this is easy. All you gotta do is just fill in your equation with the T value. So because both values are the same amount, we can just say SQ is 64.6 multiplied by 2 minus 4.9 times 2 squared. What would that be all in the calculator in one go?
109.6.
109.6? No bother there. Okay, and that is question 4 done. Okay, move on to question 6. Any questions on that? Okay. Question 6, okay. A stone is thrown vertically upwards. under gravity with a speed of u meters per second from a point 30 meters above horizontal ground. The stone hits 5 seconds later. Find the value of u. So what you have here is you're on the ground, you throw it up, comes back down again. It pretty much follows its own path directly downwards, but I'm just doing an arc just for the clarity's sake. Starts off at speed u, and then it hits the ground, and it is 5 seconds later. Can anybody just out of interest tell me what's the time it takes to hit its maximum height? 2.5, because it's symmetrical. Yeah.
It says something about from a point 30 meters above.
Oh, it does. So that's perfect, right? Under symmetrical conditions, when you throw, if you're on the ground and you throw up and it comes back down, under symmetrical conditions, the time taken to go up equals time taken to go down. However, this isn't the case for this question. For this question, you're starting above the ground, 30 meters into the air. Okay? You throw the ball up, and then it comes back down again. Okay? Now, technically speaking, you've fallen 30 meters, haven't you? You're 30 minus 30 underneath where you began. So if I do u vast in this case, S is going to be minus 30. Just minus 30. And see, one thing you got to get out of your mind about S is, okay, let's say I throw a ball and it travels 30 meters up and then 30 meters back down again. Technically speaking, it's travelled 60 meters in total. The S in these formulas is displacement. It doesn't actually take total distance into consideration. It only takes distance away from your original points into consideration. So even if you travel, let's say you travel 30 up and 20 back down again, the S value will only be worth 10 because you're 10 meters above your original height. So that's the one thing you got to remember about S in these formulas. It's actually not distance, it's displacement, and there's a difference between the two of them. Okay? So once you know that, what we're doing next is your displacement from your starting off point. And your displacement, lads, if you're 30 meters above ground, it'll be plus 30. If you're 30 meters beneath it, it's minus 30. Now, your acceleration is minus 9.8. Your u value, anybody know u value? Just says it's u. Phi, we haven't got a clue. Time is 5. Find the value of u. Select an equation. Which one do you think you should use? S equals ut plus a half at squared. Once again, we know absolutely nothing about phi. So, why use it? Next part. Minus 30 equals 5u minus 4.9, because a half of gravity is minus 4.9, and then times 25. Could somebody do me the favour of tell me what 4.9 times 25 is?
$122.5.
Sorry?
122.5.
Yeah. Minus 122.5. Bring it over to your side and add it to the 30. Or, yeah. So it's going to be 122.5 minus 30. It's 5u. Take away 30 and then divide by 5 and tell me what u is.
18.5.
What?
18.5.
18.5 sounds like a clean number. Okay. Finally, how fast does the stone hit the ground? Stone hits the ground, we have to find out what V is. So let's say V equals U plus AT. V equals U, which is 18.5 going upwards, minus gravity, which is minus 9.8.
Sir?
Yeah?
Is it not minus 9.8 until it gets to the top?
Oh no, it does it all. So for example, you're right, Tom, if you were to break it up into two parts. what I'm going to do is I'm going to get a negative answer, and the negative answer tells me that I'm just going in the opposite direction to up. So it actually still works out perfectly. You'd actually have to segment this question.
Yeah.
Okay, so I'll get 9.8 times 5, and then t equals 18.5 minus 9.8 times 5. Anybody?
Minus 30.5.
Minus?
30.5.
Now guys, what does that minus mean in this case? It means it's gone in the opposite direction to the u value. The u value is going directly upwards. The v value just before it hits the ground is going directly downwards. You would expect it to be a minus number because it's gone in the opposite direction. Okay, that's always the case. And you can just treat it all as one system and it works out every time. Alright guys, so next question.
Did you say when you're 30 meters above ground level?
Yeah, see at the end of the question we were 30 meters below ground level, and that's why, we're 30 meters below our starting point. So that's why I treated that as minus 30.
Yeah.
Okay. So it's always reference to your starting point. Eighths. Now, this one here, there used to be an old way on the course to do this, but it's no longer on your maths course, so we have to do it the long way. It's not fun. Now, a particle is projected vertically upwards from ground level at 70 meters per second. It is height 210 meters above the ground at times t1 and t2. Prove that 7t1 by t2 is 300. Okay. Anybody got any ideas? What's the first thing you always write down? Okay. Now, okay. So, it gets thrown up above the ground, and at a slice of 210, it has a speed going upwards, and it has a symmetrically the same speed going in the opposite direction on the other side. It hits the first one at T1 and the second one at T2. Okay? So then, what can we say about UVAS here? So we're going for 70 here. Any idea what V is? V technically has two different values, doesn't it? It has the first value that's a positive one going upwards, and a second one that's a negative one going downwards. No good. Acceleration? Nice. So for that, S value? 210. T value? That's the whole point of the question. We're going to get two T values. First, the smaller T value will be T1. The second T value will be T2. Now, let's make a formula out of this. Once again, S equals UT plus a half AT squared. S, which is 210, equals 70T minus 4.9 T squared. Now,
Minus 10 over 7.
huh?
Minus 10 over 7 simplified.
Just give me a second. What are you saying?
Just multiply 10 over 7 and you get it into formula.
Oh yeah, I was going to multiply by 10 first, and then. So, multiply everything by 10, get it in whole numbers. 2,100 equals 700T minus 49T squared. Divide everything by 7 now, isn't it? So, we get 300. 100T minus 7T squared. Move everything over one side. We're going to get 7T. Oh. Okay. We're going to get 7T squared. 7T squared minus 100T plus 300 equals 0. Now, I am sure if these have,
13 10.
sorry?
13 10 now.
30 and 10?
7.
Okay. The way I usually figure these out is I multiply the first one by the last one. I get 2,100, and then I break up 2,100 into 70 and 30, which are both negative. So yeah, there is something I can do there. Okay, so I have 7t and t equals 0. And what I need to do is I need to get minus 70, so I'm going to put the minus 10 over here. 70, but that gets minus 70. And then I'm going to put the 30 in here. Okay. So guys, what we're going to get next is we're going to get 7t equals 30. T equals 10, t equals 30 over 7, and t equals 10 still. That's t1 because it's the smaller amount, that's t2 because it's the larger amount. And then therefore t1 multiplied by t2, what is t1 multiplied by t2? So, t1 multiplied by t2 is going to be 30 over 7 multiplied by 10, and that equals 300 over 7 is t1 multiplied by t2, cross multiply up to 7, and we get 7t1 t2 equals 300. And that's that question complete. And there